Number 1. Find the slope of the line shown on the graph to the right. So we're just doing rise over run. Starting at this point, we count up 1, 2, 3, 4, 5, 6. To the right, 1, 2, 3, 4, 5, 6, 7. So 6 over 7, rise over run. And that's number 1. Number 2. Using the slope formula, find the slope of the line through the given points. First, write down the slope formula and identify x1 and y1 and x2 and y2. Then substitute in the numbers. We have 8 minus 3 over 2 minus 7. That's 5 over negative 5, which gives you negative 1. So the slope is negative 1. Let's type it in. So negative 1 is the answer for number 2. Number 3, find the slope of the line. Horizontal lines all have a slope of 0, so the answer is going to be 0 for number 3. 4, without graphing, tell whether the slope of a line that models the linear relationship is positive, negative, 0, or undefined, then find the slope. A student earns a 90 on a test for answering 1 question incorrectly and earns a 60 for answering 4 questions incorrectly. So we have to make an XY chart. X is the independent variable, Y is the dependent variable. The test scores depend on how many questions are incorrect. So 1 and 4 are X's, 90 and 60 are the Y's. Now we find the change of Y and change of X. We add 3 to 1 to get 4. We subtract 30 from 90 to get 60. So change of Y over change of X, we have negative 30 over 3, we get negative 10. So the slope's going to be negative 10. That means it's going to be a negative slope. Let's type all that in. So we established it's negative, and the slope is negative 10. And that's number 4. Number 5, state the independent variable and the dependent variable in the linear relationship. Then find the rate of change for the situation. The cost of dinner is $65 for 5 children and $78 for 6 children. Well, first, the independent variable is going to be the number of children, because the cost depends on that. So this is the independent variable. And since the cost depends on the number of children, the cost of the dinner is the dependent variable, because it's depending on something else. Now let's find the rate of change. Make a t-chart. Change of x and change of y. Change of x is plus 1. Change of y is 13. So we write 13 over 1, which is 13. So the rate of change is going to be 13. So let's type that in. Type in 13. And that's number 5. 7. Find the slope of the line that passes through the pair of points. So write down the slope formula and identify your x1 and y1 and x2 and y2. Substitute in the numbers. We're subtracting up top. We'll end up adding at the bottom, and we'll get negative 1.2 over 47.83. Now that has to be reduced. So just put that in your calculator and do math, enter, and you'll get negative 60 over 2,369. And that's the answer for number 7. Number 8. The pair of points lies on the same line with the given slope. Find x. So identify your x1, y1, x2, and y2, and write down the slope formula. Substitute everything in. M is 3, and substitute in your coordinates. 19 minus 10 is 9. X minus 5 is x minus 5. Now slope is rise over run. If it's a whole number, it's understood to be over 1. So write this as 3 over 1. Now we have to cross multiply. So you get 3 times x minus 5 equals 9. Distribute to 3, you'll get 3x minus 15 equals 9. Add 15 to both sides, you'll get 3x equals 24. Divide both sides by 3, and x is going to equal 8. And that is number 8. Number 9. A recipe for 10 banana nut muffins calls for 1 cup of flour. The number of muffins that can be made varies directly with the amount of flour used. There are 3.5 cups of flour available. How many muffins can be made? Well, the format for direct variation is y equals kx. Output is 10 for y, input is 1 cup of flour. So k, or our rate of change, is going to be 10. So the equation is y equals 10x. To find out how many muffins, substitute 3.5 cups in for x. Turn that into an improper fraction. So 10 times 7 over 2 gives you 70 over 2, which gives you 35 muffins. So that's the answer for number 9. 10. Determine whether the equation represents a direct variation. If it does, find the constant of variation. So we need to solve this for y. So I divide everything by 2, and I get y equals 3 over 2x plus 1/2. Because this here is not 0, it is not a direct variation. So number 10, we're going to say it is not a direct variation. Number 11. Suppose y varies directly with x. Write a direct variation equation that relates x and y. Then find the value of y when x equals 18. So first write down change of y over change of x. Change of y is 7, change of x is 6. So k is 7 over 6. Remember, direct variation equation is y equals kx. So now that's the equation. When x equals 18, substitute that in for x, and we get 21. So the value of y when x equals 18 is 21. And that's number 11. Number 12, graph the direct variation. Click to enlarge the graph. Direct variation always starts at 0, 0. Substitute another value in for x, say 1. 1 times 6 is 6, so our next point would be 1, 6. Click Save. Check answer. 13. The distance d you bike varies directly with the amount of time t you bike. Suppose you bike 12.2 miles in 1.25 hours. What is an equation that relates d and t? And what is the graph of the equation? All you need to do to find k is divide miles per hour. So divide 12.2 by 1.25, which gives me 9.76. So that means A has to be my choice. Now let's look at the graphs. Making a table of values, we see that it does not hit 30 until between 3 and 4, very close to 3. Let's see which graph matches that. Well, we can see A definitely does not. So let's check B. So these are going up by a whole number every other dash. So we have 1, 2, 3, 4, and 5. So 4, 3, and 2. So it's hitting 30 between 3 and 4 here. It's possible, but let's check the others. So 1, 2, 3, and 4, very close to 3. Here it hits it afterwards, it looks like. So it's definitely could be. So between B and C. So 1, 2, and 3. I would say not B because it doesn't hit it until after 3. So let's try C. And we got it. So it is C for number 13. 14. Suppose y varies directly with x. Write a direct variation equation that relates x and y. Then graph it. So we have change of y over change of x. So divide 2.4 by 0.6 and we get 4. So our direct variation equation is y equals kx. 4 is k, so our equation is y equals 4x. So let's put that in and graph it. Type in 4x. So now to graph it, direct variation starts at 0, 0. Slope is 4. Go up 1, 2, 3, 4. To the right 1. That's number 14. 15. Y-intercept is 4, the slope is 2. So we start at 4 on the y-axis. Then we go up 2 to the right 1. Press save. Check answer, and that's number 15. Number 16. Find the slope and y-intercept of the graph of the equation. Y equaling a number is a horizontal line, and all horizontal lines have a slope of 0. Y-intercept is -9. Y equals -9. And that's number 16.